Here we go again. We're going to be covering point estimators and population parameters. By the end of the video, we'll be able to identify and calculate the appropriate point estimators and identify the corresponding population parameters. Let's consider the following example. Let's say I have a total of 3 classes, and I'm going to be sampling a total of 10 students out of these 3 classes. On their first test score out of 100 points, I have the following grades of these 10 students. And if I chose to, we can find the average of these 10 students by adding up all these values and dividing by the number of students I sampled, in this case 10. This would give us the average of these 10 students to be 64.4. We're going to use X bar to represent the average or the mean for our 10 sample students. The sample average on the first exam, X bar, equals 64.4. We are going to call X bar the point estimator for the population of students. If X bar is the point estimator, then what does the students represent? The students are the population mean, mu, refer as the population parameter. From our first example, we can start developing a definition for point estimators and population parameter. So let's look at our first definition here. A point estimator is a statistic that provides an estimate of a population parameter. So this is telling us that the point estimator in our example was X bar. This represented the sample of students, our average X bar. And the population parameter represents the entire class that includes both all of our samples and the original set of students. So that's one way to see point estimators and population parameters. In our second definition here, the value of a statistic for a sample is called the point estimator. So the value in this case was the value we found that X bar is equal to 64.4. The statistics represent all the information. Again, the entire population of students, the population out of all 3 classes. And when we found the X bar value, that represents the point estimator. So here's something to note. Any population or a statistics can have a point estimator. So all this says is that if I have any set of data, we can do some math and create an estimation that represents this data. Another way to think about these definitions is a statistic is an estimator of some parameter in a population. And those are our definitions. Here's a table of common population parameters and point estimators. In our first example, we were focusing on averages. So the population represents the total of the 3 classes. And if we were to find the average of the total of our 3 classes, this will represent our mu value, the mean of our entire population. what ended up happening, we took a sample out of our 3 classes, which was the 10 students, and this represented X bar, which gave us the value of 64.4, which is the point estimator. So essentially what we can do here is to think about whenever we have a population parameter, this represents some kind of total. And whenever we have a point estimator, this represents a sample from the total that we use to calculate some kind of value. In our next example, we will focus on standard deviation using the exact same type of data. In example 2, we're going to revisit example 1, where we took the sampling of 10 students. Recall that we were able to find the mean of the students, meaning X bar, the average of the sample, giving us 64.4. What we now want to be able to do is calculate the variability, meaning some kind of spread. We're going to estimate the population standard deviation by using the 10 sample students. Now, by measuring the variability, notice that our equation is slightly different than what we would use for the standard deviation for the population. Since we are talking about a sample, we're going to use S sub x, where in this case, the denominator is going to be n minus 1, where the lowercase n represents the sample, and capital N is actually the total population. Since we only have a sample, we're going to use this setup instead. And we're going to find that our standard deviation of our 10 sample students is about 22.809. So now we have the population standard deviation. But wait, this is an estimate of the population standard deviation because we only have a sampling of 10 students. So the point estimator in this case is S sub x, and the population parameter is sigma that represents the standard deviation. So using the sample standard deviation S sub x as the point estimator for the population standard deviation, sigma. And if we pull up our table that we had from before, this indicates our population parameter is standard deviation, and then we use sigma. Our point estimator, which is the sample standard deviation, S sub x. So in this problem now, our point estimator is going to be S sub x, and we use the standard deviation where in our equation is n minus 1, and again, n in this case is 10, that represents our sample. Moving on to example 3. Example 3. What proportion P of US adults would classify themselves as vegan or vegetarian? If we survey 1,400 randomly selected US adults and 125 adults said they were vegan or vegetarian. A. Identify the point estimator you would use to estimate the parameter, and B. Calculate the point estimator. So here in this problem, we're looking at the proportion P of US adults. This tells us that our parameter represents P, which is the proportion of US adults. And in order to answer part A, since we're talking about proportions, P hat will represent the proportion of the sampled from the survey, US adults. So p hat is our point estimator. Ta-da! And that's the answer for A. In order to answer B, we're calculating our point estimator. Since p hat is a proportion, our proportion is some kind of ratio or fraction. So what we're going to have is the number of individuals who classify themselves as vegan or vegetarian all over the sample group. In this case, we're going to get 125 over 1,470. And if we're to punch this into a calculator, we should get something close to 0.085. We can summarize all of our solutions of example 3 as follows. In part A, use the sample proportion p hat as the point estimator for the population parameter p. And in part B, the point estimator is based on 1,470 surveyed US adults, where 125 said they were vegan or vegetarian. So our calculating p hat is a proportion. Right here, we have our fraction, vegan or vegetarian over the sample survey. This equals 125 over 1,470. This gives us 0.085. And this is perfectly fine. Since we're looking at some kind of proportion, we're looking at some decimal value that's less than 1, because we're really looking at some kind of percentage where 1 is representing 100%. And that's it for our example 3. Now it's your turn. Here are 2 exercises for us to do. Just recall that simple random sample can also be abbreviated as SRS. So type up the results of these questions, enter it down below, and at some point we'll go over these. However, huzzah, we're done for now.